5294. Given, glider A wingspan is 48 feet average wing chord. 4.5 feet glider B wingspan is 54 feet average wing chord is 3.7 feet to determine the correct aspect ratio and its effect on performance at low speeds. A. Glider A has an aspect ratio of 10.6 and will generate greater lift with less drag than will glider B. B. Glider B has an aspect ratio of 14.5 and will generate greater lift with less drag than will glider A. C. Glider B has an aspect ratio of 10.6 and will generate less lift with greater drag than will glider A. The correct answer is B. Aspect ratio is a measure of the efficiency of a wing and is calculated by dividing the wingspan by the average wing chord. In this case, glider B has a higher aspect ratio, 14.5, compared to glider A, 10.6. Higher aspect ratio wings tend to generate greater lift with less drag, particularly at low speeds. Glider B's higher aspect ratio means that it has longer and narrower wings compared to glider A. This allows glider B to generate more lift for a given wing area, resulting in improved performance at low speeds. It can maintain a higher lift-to-drag ratio, allowing for longer glides and better overall efficiency. Therefore, glider B with its higher aspect ratio will generate greater lift with less drag than glider A at low speeds. 5295. The best L/D ratio of a glider is a value that A. Varies depending upon the weight being carried. B. Remains constant regardless of airspeed changes. C. Remains constant and is independent of the weight being carried. The correct answer is C. The L/D ratio, also known as the glide ratio, is a measure of the efficiency of a glider and represents the ratio of lift to drag. It indicates how far the glider can travel horizontally for a given altitude loss. The best L/D ratio represents the optimal trade-off between lift and drag, maximizing the glider's efficiency. This optimal ratio is achieved at a specific angle of attack and airspeed, regardless of the weight being carried. It is a characteristic of the glider's design and remains constant under normal flight conditions. While the glider's weight can affect its performance, such as the rate of descent or minimum sink speed, it does not change the best L/D ratio. The glider's optimal glide performance, indicated by the L/D ratio, is determined by its aerodynamic design and remains constant regardless of airspeed changes or the weight being carried. 5296. A glide ratio of 22:1 with respect to the air mass will be A. 11:1 in a tailwind and 44:1 in a headwind. B. 22:1 regardless of wind direction and speed. C. 11:1 in a headwind and 44:1 in a tailwind. The correct answer is B. The glide ratio represents the distance a glider can travel horizontally for a given altitude loss. It is a measure of the glider's efficiency and is determined by its aerodynamic characteristics. The glide ratio is independent of wind direction and speed because it is a ratio of the glider's horizontal distance to the vertical distance descended. The presence of a headwind or tailwind affects the ground speed of the glider but does not change its glide ratio. Therefore, regardless of wind direction and speed, a glider with a glide ratio of 22:1 will maintain that ratio. It means that for every unit of altitude lost, the glider can travel 22 units of distance horizontally.